神の倉山を登り、安戸です。あ、郵便局ある。
Was make snowflakes fall on the page. That's why we say that we may not be really conscious about the opportunities of JavaScript at that moment. But then things went on, and we really wanted to be able to load new content on the page without reloading the page. But then we had to wait 10 years and have Ajax requests. And then we were technically done. We were able, at that point, technically, to build a fully interactive application within the web page. But we didn't go straight to the point, right? We all know that we had a really big problem of separation of concern, because at that time we still sent chunks of HTML through the wire in response to Ajax calls. So also, we didn't have Node.js, so we were writing in JS in the front end and then on the back end in Ruby, PHP, Java, whatever. So in 2010, first generation of UI libraries came out. I'm talking about Backbone, Angular, Ember, and many more, but those are the most famous. And what happened at that moment is that we were able to pull the view logic out of the back end and just leave that concern to the front end and make the server just expose a REST API and make pure JSON data flow through the wire. So we were able at that point to split concerns and teams, which was great. We just had to make a contract between the front end team and the back end team, and that was a human problem, very easy to solve. And then we were done. It's okay. Calm down, Steve. Look at how the native application engineer did the UIs. And look at how we did the UIs. That's the code that we needed to write in order to nest the view in another backbone view. And when I realized that, I felt pretty much like this. We definitely need to do something. And at this point, it's really a concern of developer experience. And it's very interesting for me what drives those innovations. At a certain moment, it was just user experience. Now, it's developer experience. Be more productive. 2013, second generation of UI libraries, React, Angular, Vue.js, Polymer, Psycho.js, many more, which introduced a lot of new things, but here what I'm interested about is the concept of component. Components, as we all know, are the basic bricks that we build our web page with. And the interesting thing about components is that we can really describe every aspect of that chunk of interface in the same place. What I show you here is a Vue.js component that I really like because it's very clear. You get three tags: style, template, and script. And that's all you need to define a component. The beauty of this is that each aspect is defined in a different language, and the language is very specialized for that precise thing. Also, component exposes a clear API of input and output, props and actions or events, which allows the developers to exchange and distribute the component to other developers so that you don't have to bother what's inside a component that you install from NPM, for example. And this will allow us to create tools like this, the Polymer Designer, which today is just a prototype, but I'm sure that in the future we use more and more RAD UI composition tools. The great thing about the Polymer Designer is it really generates real Polymer code that you then can work on. So we've gone a long way so far, so what do we still need? Today, if we are offline, even if all our assets are stored in the browser cache, we want to access a website, we've been there yesterday, and now we're offline, we see the dinosaur. Native applications don't do that. You open a native application and you have some content that you've been visiting before, you can see it. We have the dinosaur. Why? Let's kill the dinosaur. Let's provide the user with some real, compelling offline experience. And then what we are doing today is first-class applications, web application. And why wouldn't be present among the other application of the user? Why don't we have an application icon within the application menu of the user? And then native application can bother the user with personalization. Why shouldn't we do that? Actually, all these things are possible today, and they are known in this terms. Progressive web application is like a technology bundle that Google pushed forward a lot, and which really, to me, is the last step that we need to make in order to provide a real, fully interactive application-like experience to the user. But unfortunately, it's not supported by all the browsers. Guess who is supporting that? Chrome and Firefox. Let's see what happens. My dream is actually to be able to leverage all that technology and really, make real applications in the web with web technologies. Data. I want to talk about data because we've been talking about UIs, and that's one thing that we deal with, and then the other thing is data. We always have to manage how the data flows through our application. And the main problem is what happens when data changes. The main promise that all the UI libraries we use is to keep the data in sync with the UI. Or the opposite, UI in sync with the data. Okay, this is a piece of junk code that I show you. So please, children, don't do that at home. Okay? Here, where's the data? Because we check the DOM, and then if the menu is closed, we put the class, and if the menu is open, we remove the class. So where's the data here? Where's the state? The state, my point is the state has always been there. In the previous slide, what we did is just check the DOM for the application state. And we basically use the DOM as the representation of the application state here, which happens to be a very bad idea. So, yeah, the state has always been there. The only shift we've been doing is to choose to define the application state in another way, to separate it from the DOM, and put it in global variables, like here. Again, junk code, don't do that at home, children. Here we represent the state of the menu with a global boolean, and then we keep the boolean in sync with the state of the DOM node that we use to represent the menu. So that variable is the state, the data. And the great thing about React, when it came out, the great revolution to me, is not only that they abstracted the DOM through the virtual DOM, but they really enforced this idea that we should manage a state somewhere which is completely independent from the UI state, and then we just use the components, the React components, to map that state to the DOM, but never access directly the DOM. Or yeah, sometimes you don't have the choice, but it's commonly known as a bad practice. So I suddenly became aware of this concept of state. So you have this state and you have to do something about it. But the question that React doesn't answer is, where should the state live? You have all these JavaScript objects, and where do you put them? So if you use vanilla React, you can scatter your state across component and let every component manage its own state, like we did in Backbone, like we did, all the time. And as long as the application grows big and complex, we understood that it's a very good idea to gather all the state within a store, which is what Redux enforces, what Flux enforces. This is not an invention of Redux, but I think that when Redux came out and when Flux came out, that this idea was really, blatantly shown to the community, so we suddenly were conscious about this. So when the store is there, what happens is that we introduce a new layer to the front end, which stores the state. But the state of the application contains two sets of data. One set from the user, which is basically it's calculated from the interactions of the user with the UI, like some clicks here and there, or some forms that are filled. And then the other set is the data coming from the server. And if we use the store to keep the data that comes from the server, we're actually talking about the local cache. And the local cache is always something that we somehow want to keep in sync with the thing that is being cached by the local cache. So, in this case, we're facing a new data binding problem. The binding between the state of the store in the front and the state of the backend, the data in the backend. And how do we implement this data binding mechanism? By calling the REST API. I really don't like REST APIs. I think they really don't fit our needs. And the third person in this conference talking about the problem of overfetching and underfetching. So I think that it's useless to talk about it right now. So I think we can take the time that I've used to this to do something more fun, like having a chat with the captioner. With a captioner. Hello, are you enjoying the conference? I wanted to thank you for fixing all my English errors. And I also wanted to really compliment you for the job you've made during Jafar's conference, because actually Jafar talks faster than my brain can think. And all the things that Jafar said were actually written down there, so it means that these persons can type faster than I can think. So you guys are doing an awesome job, so thank you very much. Please. Overfetching and underfetching. So this is, we always say we are friends, so the REST API doesn't fit our needs. We do round-trip requests to get a lot of useless data, and we bloat the network, and then we have this first world problem of tight coupling we don't really like. So how do they do in the backend? They query. Basically, they send a query to the persistent. So why do we do the same thing? This is the purpose of GraphQL and FileCore. We've seen GraphQL before, and FileCore is another thing that basically solves the same problem on the server. And there's another one, which is called OnNext, which I won't talk about because I don't understand anything in ClojureScript. But the next talk is about this. So what happens on the server? You just have one API endpoint, and you send a query. And then you have exactly the same data that you want. Nothing less, nothing more. And now we're over with overfetching and underfetching, but still, we don't have a clear way to leverage the fact that we can cache that data. The data that comes from the server, we can keep that on the client, and then use it to optimize the further requests that we want to make to the server. And that's where the FileCore client and Relay come into play. These are the new kids on the block. And basically, the FileCore client interacts with the FileCore server, and Relay interacts with GraphQL. And what they do is, in the same way that React introduced this abstraction layer between the developer and the DOM, saying, don't worry about the DOM. Just give me the state, and I will patch the DOM in the best way as possible. FileCore and Relay do the same thing with the network. They are saying to the developer, don't worry about the network. Stop querying the network. Stop sending requests. Just ask me the data. I will provide you the data as soon as possible, in the best way as possible. So they are managing all the data caching for us. They are managing all the request optimization for us, and we'll see that in a moment. And they just let us specify that we need and just wait for the data to arrive. In this case, we are introducing a new OGM layer to the front end. I say OGM because FileCore really work with Graph, because actually it's the best way to model our data. And the interesting thing here is that we are starting to consider the backend as some sort of resistance layer that we about. We just know there's some sort of latency, and that we don't bother about it. That time. That's when things become interesting. Okay, what are you seeing here? Okay, this is what I have in my backend. Let me just resize the window. This is a list of products that I was thinking to search for the products I have this. These are Italian food that I sell to my colleagues at Kazoo. So what I make here, I'm actually FileCore, okay? It doesn't mean that I think that FileCore is the best solution ever. just that Falcor isn't coupled with React. Since I'm not a React developer, I use Vue.js. It was just the best solution for me to show you the idea behind the thing. So here is, we are querying with this model variable that I've exposed to the doing as global, and I just say get value, and then here I specify my query. In the query, the nice thing about Falcor queries is that they are really similar to the JSON syntax. So I have this set, which is products by ID, and this is the ID of the Parmesan cheese that I want to see, and this is the title, okay? And then get value returns a promise. The real type is actually unobservable, but it really behaves like a promise. So I said, then, when the data is available, I want to show it. So here's the data. Okay, let's take a look at, this is the query. Am I right? Yeah. Yes, this is the response of Falcor. Okay, it just sent you the title. What happened on server side? Let's see. This is my Falcor code on the server side. Falcor on the server is just an express middleware that you just plug a router to and then specify what your routes do. So, okay, this is my router create class, and then I define a route. This is the matching pair. So that's how I tell Falcor what do you have to match in order to enter this route. And then I specify the method, which in this case is get, because I just want to get data. Methods can be get, set, and call. So in this case is a get, which always returns a promise. And then here, this is my code. It's just I make a call to Kazor to get some data, and then when the data is available, I just resolve the initial promise with the data I format in the Falcor syntax. Okay, is that okay for you? It doesn't make sense. Okay, can you read? Do you want me to? It's okay? Okay. So basically when the data come back, I have my title. So now let's try to ask another field here. Say I want to get the description of my product. Okay, I have an error. Yes, it's always the same, because I always get caught by this. In fact, when you want a value, you use get value, so you just have the value. And when you want multiple values, you use get, which actually returns a JSON graph object. So here you can see I have my title and my description. But look at the response of the second request. Falcor knows that I have the title in cache. So even if my query was asking two fields, it tells the server, okay, just send me just the description field, because I already have the title. And what I really like about it is that Falcor tries to make this metaphor, to create this illusion to the developer, which is just code as if the data was present on the local machine. Just say like it was synchronous, okay? Like, don't worry about where's the data, where comes the data from. I just manage it. And so, what if we could code like really everything was here and we could synchronously get the data? Get the data. Well, we actually have seen a very interesting talk by Jafar today, and we've seen all this async await thing. So take a look at this function I'm writing here. Load model. So ask the Falcor model 3 fields, but we use async await. So we don't have to put the then here. It's just like synchronous code. And then right after the Falcor model.get, we JLog, we log the value, like if it was synchronous. And the great thing is that it works. This is the response of the 3 fields here, so it worked. And it worked. I'm pretty shocked about it. I have to watch twice all Jafar's talk to understand, but I was happy about it. So, the great thing about this kind of approach is that we can collocate data requests. So, collocation means that within our components, we can specify the data we need. Until today, I used to do Wix with it, which is a Flux implementation for Vue.js. So the place where I specified the data that my component needed was in a synchronous action, so it was completely separated from the component. Here, I'm in this product list component, which is actually, let me just go to the homepage of my website, okay? So this is a product list with all the products, and my list, this is the code of my component, the list component, and here I specify exactly the data that I want for my component, which doesn't mean that the component is in charge of fetching the data, because this would imply tight coupling. In this case, the component just expresses the need for data, and then Falcor is in charge of it, which Falcor is actually completely separated. But hey, it misses something, no? This is not a proper e-commerce platform. We have the name of the... Okay, it's in French. My colleagues are French. It's not their fault. I'm sorry. We are not showing the price. Oh my God. Let's get the price. Look at the price. I think you already know it. We just have to add a field to our query and don't touch a single thing on the backend. Any hot reloads? What can we ask for more? Great. So this is the power to me of Filecore, and it's something we can do obviously with GraphQL as well. This is not the same approach, but where's the menu here? Duck, and it works. Oh, we don't know what. We have made a lot of progress actually. But I think that today we are kind of concerned with speed. Okay? Many people are complaining about speed, especially on the mobile web, and this is not good. I think one thing that we can do is just drop REST APIs and just go query. And use solutions like Filecore and Relay and GraphQL and save a lot of round trips and useless data overfetching. Of course, these solutions are pretty new and there's still a little bit of friction to adopt them. It's not very easy to set up a GraphQL or Filecore server. We have to grasp things. But we are especially concerned about this kind of problems at Kazoo, and we try to work to provide a common running backend that just provides you a Filecore model or GraphQL query endpoint. And I hope that in the future we'll be able to have all these things out of the box. HTTP2. Many people in this room have seen the talk that we've seen on Tuesday about HTTP2. HTTP2 is here. It's going to dramatically speed up our things, and network round trips are not going to be such an issue, so let's adopt it. It's my dream to see a fully worldwide HTTP2 web. And then I'll talk about data binding. Data binding comes down to observing. We've seen that keeping things in sync is a common pattern. We have this pattern since the 70s. We know that observation is the best way to keep things in sync. In our UIs, we use the components as observers that then map the state to the DOM. But all the frameworks that we use implement this in different way. Events, dirty checking, virtual DOM, reactivity. I think that data binding should be embedded into the language. And this is what Jafar Stowe was about. The key solution, the most elegant solution to this problem. And actually, all the RxJS implementation are going through this direction. I hope that the RxJS implementation will be embedded into JavaScript soon. This is one of my dreams. And also, virtual is good because it introduces this abstraction, which actually works very well. And it's also good for performance. Because imagine we have a DOM change. We trigger it, and then the browser goes on and restyles, relayouts, and repaints everything. This is very costly. Another DOM change, another round of restyle, relayout, and repaint, and so on. What the virtual DOM does is buffering the DOM changes, and then trigger them, flush them all at once, and save a lot of calculation of restyling, relayouting, and repainting. I was asking myself, why don't we make virtual DOM native? Why don't we make browsers expose some kind of virtual DOM API, something that would allow us to say, hey, look, I have this change, just buffer it, then this one, and this one, and this one, and then just flush it. And then you do all the calculations. Obviously, virtual DOM also computes diffs, so it doesn't mean that virtual DOM would be completely useless, but I think that virtual DOM libraries would be lighter, so it would speed up page loads because we would have to load less JavaScript this way. So let's go back to the beginning of the talk and just, why are we doing all this? What was the problem since the beginning? We are spending 20 years and more trying to provide the user with a fully application-like interactive experience. And we're trying to do it through some kind of software that executes in a distributed environment, which is instantly accessible with just a URL. And this application has to be executable in all the existing browsers, and there's a whole bunch of them, on all the existing OS running on all the existing devices, in all the possible network conditions. And these are all factors that we don't control. And this is just in order to achieve the largest amount of users and in the end make them happy. I think that we have a lot of things going on in our community because the problem is complex and it's not solved. And we are finding solutions that are just awesome. Think about the network abstraction introduced by Relay and Filecore. This can benefit all the industries that work with this video application. And now you as a developer, an Android developer could benefit from having the network abstracted and don't have to bother about it anymore. So from our community, we are really introducing this great innovation that we can spread around. And if you take a look at how the front-end environment evolved, we can see that the stack is not very different from the native application stack, especially if you consider that the backend is like a persistence layer if you abstract. Today we have a front-end that embraces the full stack. And I think this is possible because the language that we use has evolved a lot, and it's now a first-class application programming languages. And I'm talking about JavaScript, which is the language of our community, the language that we use every day to express the problem that hassle us every day when we wake up. We have people that work a lot, that are really concerned by this problem. We spend a lot of time working on free open source projects. We spend a lot of time on the social network trying to communicate with other people and find solutions, maybe arguing sometimes a lot, because these problems matter for us, because the users matter for us. I think we are an awesome community. My friend Steve would say, I have 4 words for you. I love this community. That's the way he would do it. I think we are not a community made of hipsters. We are a community of dreamers. And let me say that I think that our dreams are close to come true. Thank you very much. I hope you enjoyed it. It's very easy just to start writing test cases. And this piece is the first thing before you start writing test cases. You need to know what you're trying to achieve. Okay? And the other rules will fit into this because they were reflections of what you're doing with this question. So as students, I keep writing tests for a little tiny thing. He found out that actually what he was doing was he was capturing the behavior of the system. Right? And that's what we're doing. Right? Tests are at one level sort of like the inputs of your code. This is your test capture. You think about it.
えた？間違えたわ。この次だった。間違えた。道間違えました。
Try to make your test as fast as you can. If you don't, then they'll be run by somebody else because we're all getting to. But the other testing will run it a little bit later. They'll do it less often. They'll do things around trying to deal with that problem, and then you end up with you have one test to run locally, or you have your favourite set, which is the other problem. Because let's be honest, what developers do, if they have a big test suite, the ones that run fast and they run loads because they can do this in 30 minutes. I just had a question on this. Do you have any experience, like heuristic about like how long the test should run before you start worrying about trying to speed them up? So the question is the heuristic. You allow a test to run before you speed it up. Milliseconds. Actually, that's the wrong answer. The right answer is how long. It's like how big is your test? How long does it take? Right. So I would say there's to give you an example. There's projects back where I work, and they have been working on moving their test suite. How long it takes to run the whole of the test suite, and they say going from ski to T. They said they used to take the ski trip to run their tests in 2 weeks. And they said this is ridiculous. You need to get it down to how long does it take you to cook your cup of tea. And so it's an order of magnitude thing. That makes more sense, because you will run the test, and if they take too long, you won't run the test. Right. So we have a test suite that we run regularly from our continuous integration system, and we try to make sure the whole test suite runs in 2 hours or so. So you can push code multiple times a day and get test results multiple times a day. And so it's less about the speed of any given test than the aggregate. It is something to keep an eye on, right? So if you have And we have high variability as well, right? We have some combinatorial unit tests that run hundreds of thousands of cases and they take a few minutes. Maybe you have one thing that takes 100 milliseconds, something like that. But the aggregate is the thing to watch out for. Yeah. I mean, to be honest, when you get into test suites that take a long time to run, then you start applying different sorts of techniques. So then you start thinking about which of these tests, do I run this test or versus this test? And you might be, how long does the test take to run? But you might go, this test has never found a bug. So maybe swaps them. And that's the debate. It's the system test team who's put their expertise in trying to figure out how they matrix these massive problems so down to something manageable. Right, okay. 26. Have to repeat it? Okay, yeah. So this is a fun one. So this is, I think, you can't be absolute without saying absolute. I think this is definitely something to strive for, but I have to admit that it is probably not possible to achieve in practice. This is something I have this test, and it passes 99% of the time. So what? Is that good enough? No, because if you have a continuous integration system, you'll be running this test several times a day in several different configurations. In the course of a week, you might run this single time hundreds of times across many different platforms. So therefore, this 9% is pretty reliable, but it isn't because this generate maybe a dozen spurious failures every week in a continuous build system. And then if you have more than one test, if you have thousands of tests in your test suite, and a handful of them are flaky, what this is going to do is give you kind of a noise floor of test failures. And so you're going to look at that and say, oh, okay, well, that's our noise floor, and that's normal. Yeah. And the problem that will occur, that happens is, if somebody introduces an actual bug and it causes this test over here to fail regularly, you're never going to notice it. Yeah. And so noise, having this noise level of intermittently failing tests is going to obscure real quality problems. The problem is, in practice, it is very, very difficult, as you all know, since you all raised your hands, and as we know, it's very difficult to get a test suite that is 100% reliable. But it's really important to work on it. And so I think there are no magic bullets here. I think the thing is, if you have to hit it at all levels. If you're reviewing test code, and you should be reviewing test code, but when you're reviewing test code, you can look at it and say, oh, is this a potential source of intermittent failures? And they do creep in. Occasionally people will put, oh, I can't test all of them, so I'll use a random number generator. Well, okay, so that's the source of intermittent. People will, it's hard to imagine that people will inadvertently introduce intermittent failures from time to time and not realize it. Sometimes there's sensitivity on the environment that you have to build up robustness in the tests. So there are a lot of things that, there are a lot of damaging things that can occur if you have a test suite that is not reliable. And, it'd be nice to be able to wave a magic wand and say this test suite is reliable, but I think what you need to do is just get down and do the work. So, yes, do you look at tests that have been written from this point of view? Do you consciously think about the design of a test to see whether it's actually deterministic? Or do you think you probably just did it when you get wrong? Well, so again, when I worked on GDK, it wasn't my test suite, mostly with my people long ago. And so what we did was we worked on tests that attracted attention by just gathering statistics over how frequently those tests failed and then examining ones that failed most frequently. And I think it's a very pragmatic approach. The problem is that if you have a large test suite, sitting down and attempting to review all of the tests is just impractical. So we looked at the tests that attracted our attention. So another thing is I think it is important to